Hello everyone, I'm Kanchana working in SNS College of Engineering as an assistant professor in the Department of Chemistry. In this video now I'm going to see about instrumental methods of analysis, AAS, Atomic Absorption Spectroscopy. The technique is based on the fact that ground state metals absorb light at specific wavelengths. Metal ions in a solution are converted to atomic state by means of a flame. Light of the appropriate wavelength is supplied and the amount of light absorbed can be measured against a standard curve. Instrumentation of atomic absorption spectrophotometer. Basic principle. The technique of FAAS requires a liquid sample to be aspirated, aerosolized and mixed with combustible gases such as acetylene and air or acetylene and nitrous oxide. The mixture is ignited in a flame whose temperature ranges from 2100 to 2800 degrees Celsius. During combustion, atoms of the element of interest in the sample are reduced to free, unexcited ground state atoms which absorb light at characteristic wavelength. The characteristic wavelengths are element specific and accurate to 0.01 to 0.1 nanometer. To provide element specific wavelengths, a light beam from a lamp whose cathode is made of the element being determined is passed through the flame. A device such as photomultiplier can detect the amount of reduction of the light intensity due to absorption by the analyte, and this can be directly related to the amount of the element in the sample. Atomic Absorption Spectrometer block diagram. Source: hollow cathode lamp HCl. A cathode lamp is stable light source which is necessary to emit the short characteristic spectrum of the element to be determined. A different cathode lamp is needed for each element, although there are some lamps that can be used to determine 3 or 4 different elements if the cathode contains all of them. Each time a lamp is changed, proper alignment is needed in order to get as such light as possible through the flame where the analyte is being atomized and into the monochromator. Hollow cathode lamp. The lamp is filled with an inert gas, an argon or neon. When a potential is applied, it causes the gas to become excited and it is driven towards the cathode. Metal atoms are then sputtered off the surface of the cathode. Hollow cathode lamp. Repeated bombardment of the metal atom by the gas causes it to be excited. It ultimately relaxes, providing specific atomic emission lines. Chopper. Function is to fluctuate the source output. It is circular, divided into 4 quarters. 2 are mirror and 2 are open. The disc rotates at high constant speed. When the mirror quarter in front of the lamp, it reflects the radiation. The second moment, the open in front of the lamp, and the radiation passes through the sample being absorbed by reaches the detector in pulses. The detector converts the radiation to alternating current signal and amplified it. The radiation coming from the flame itself and from atoms excited by the flame will reach the detector continuously and converted to direct current signal which can be suppressed and eliminated. Atomizer. First one, flame atomizer. Liquid samples introduced to atomizer through a nebulizer. Uses a slot type burner to increase path length. And another one, non-flame atomizer, a graphite furnace heated electrically up to 6000 degrees Celsius and contains a ribbon or board in which one can inject the sample. Upon heating the furnace, the sample is ascend then atomized by action of heat. Atomizer. Advantages of non-flame atomizer: the sample volume is small, no need for fuel oxidant mixture, and no flame noise. Solid sample can be used directly. Heat distribution is uniform and temperature is steady, and unusual high sensitivity. Atomizer. Different flames can be achieved using different mixture of gases depending on the desired temperature and burning velocity. Some elements can only be converted to atoms at high temperatures. Even at high temperatures, if excess oxygen is present, some metal form oxide that do not re-dissociate into atoms. Inhibit their formation. Conditions of the flame may be modified, achieve a reducing, non-oxidizing flame. Characteristic of a different flame source, Reynolds 1970. Monochromator is an optical device that transmits a mechanically selectable narrow band of wavelength of light or other radiation chosen from a wide range of wavelengths available at the input. And detector. The photomultiplier tube is almost universally used as the detector type in AAS. The type of detector found in AAS is the photomultiplier tube. The principle of operation is the emission of electron upon exposure to the radiation. The detector contains a photoemissive cathode and series of diodes. Thank you.